So somebody sees a car up ahead of themselves and they want to reach the speed limit because clearly they have been traveling too fast. Of course, anytime that you're dealing with humans, there's a reaction time. So let's go ahead and start as we always do with an origin. And so we can have the initial position. I'm trying to do initial position. And so what I'll do is there was 1, 2, 3, 4 that we'll have a couple of dots with the same spacing, and that would represent the reaction time. And then they're going to start slowing down. And then we'll assume at this point they've reached the appropriate speed. And so during this initial part of it, the acceleration is 0, but then during this part, that there is an acceleration that is in the opposite direction of the way they are traveling. And then during this portion, that the acceleration is again 0. And so for part D, that we have two cars, and well, a car and a truck, and they're moving opposite directions. And so again, you're in charge of the way you want things to be. I typically draw to the right as being the positive direction, and if we were to be true to the cardinal directions that we typically find on a map, to the right is east, and so to the left would be west. And so we've got a car that's initially at rest, traveling west and accelerating. So that must mean that the dots are getting further apart because they're moving faster. And we have a truck that is moving towards the east, and so they start out at an initial velocity and then they start to slow down. And so there's, we don't know necessarily how much the slowing down, etc. is. And so my assumption is that somewhere in this time frame is when they passed each other safely. And we'll get into how you deal with all of this once it comes time to actually do the problem solving. But that's the next two.